Hi, I'm John Amond. I'd like to work with you a little today about calibrating pH electrodes. And we have a MicroLAB. Here's a quick slide of our experiment. We're going to take solutions of known pH, connect it into the MicroLAB, read the signal, and then let MicroLAB create a calibration equation. So when we put a solution of known pH in, the MicroLAB sends a number that is this value. Okay, let's take a look at the apparatus over here. And I've got a pH electrode. I've got a beaker of water back here to rinse the electrode between measurements. And I've got 3 buffers. pH electrode has a little vial on the bottom that contains a buffer, a constant pH solution. I'm going to put it in the water just to hold it for a minute here. And I'd like to now call up the MicroLAB software. We will pick the MicroLAB experiment. This comes up and we have 6 areas on this screen. Here's where the sensors are selected. Controls are here, experiment steps, and data presentation, graph, data table, and digital display. I'm going to add a sensor and we're going to add a pH sensor. So I look down my list here and it says pH or dissolved oxygen. That connects here to this BNC connector. I'll click it so the software knows I know where I'm going to plug it in, and I'll choose pH. Now, let's calibrate it. And I get a choice here. I can either read a calibration from a file or I can perform a new calibration. We're going to calibrate this, so I'll click this. Here's the graph where we're going to be doing calibration. Here are my curve fit choices, and we're going to add a calibration point, and we get an equilibrium display. If you notice, I've got a green spot in the middle. It's moving just a little bit. The sensor history is a graph of the output versus time, and here we put in the actual value. It's important when you do a calibration point that you wait until the sensor equilibrates. pH electrodes take a little while, maybe as much as a second. I'm going to start with a 4.0 pH. And if we can switch over here, I've got that in a vial, and I'll take the top off, take the sensor, and as I put this in, you're going to see the sensor react. And it switched way high, and now it's kind of stabilizing. I'll stir it around a little bit. And you can see in the center, the green equilibrium display is stable, and the graph is pretty stable at this point. So what I've got right now is the number coming out of the sensor for pH 4. So I'm going to say, okay, I'm going to grab that point, and we got it. I'm going to take the sensor out. Let's add another calibration point. This one, I've got pH 10 buffer. So I'll say 10.0. And if you notice, boy, it really shifted. It went way down. Actually, this one equilibrated very rapidly. So I'm going to take that and say, okay, I like that data point. Got it. And I will put the pH electrode back in the buffer. And I have 2 data points, one at pH 10 and one at pH 4. And if I do a line, correlation coefficient 1, and you say, gosh, what's with that? 2 points define a line. It has to have a perfect calibration because they're just 2 points. And so the question is this calibration equation we have reasonable or not? Well, if the points are accurate, it is, but you have no way of telling that it's reasonable or not. So let's add another point, and I have some pH 7 buffer, and let's open that up and we'll switch back here. And if we could watch the graph as I put this in, there we got it, and changed rapidly. And let's wait for that to equilibrate. And that looks pretty good. So I'll say, okay, we'll grab that point. And we now have 3 data points. If I do a curve fit, it's almost a perfect straight line. The correlation coefficient has 4 9s in it. All we did with that 3rd point is prove that our first 2 points were accurate. Now, since we have a good calibration, I can accept and save it. Units are going to be pH. I'm going to call it pH Cal November 27th. And I'll save that. I'll say finish. The water solution is about pH 6.9. So what we've done is take an uncalibrated pH electrode, use 3 known pH samples to calibrate it, and we got a good calibration. And that's basically all there is to it.